From the previous part, we know which business rules occur in the notes feature of the app, and we have already created the failures used to let the user know when such rules are not being followed. How can we enforce these rules though? Well, with validation and value objects. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this part, we are going to go over stuff which you have actually already seen when we were implementing the email address and password value objects, but this time it will be a little bit more complex because we are going to need to combine multiple validation rules in one value object. What do I mean by that? Well, for example, a to-do item can not be empty, but it also has to be only one line of text and not multiple lines. So this means there will be multiple validation rules combined, whereas what we currently have built even previously in the previous parts, for example, the value objects for the auth feature, these contain only one rule: validate password or validate email address. We can afford such a thing here. And you might be thinking right now that, hey, all right, but email address cannot be empty as well. And email address has to have only one line as well. So why do we not have multiple validation rules even here, right? Well, that's because that email address validation actually uses a regular expression, and this is only gonna be valid when the email address is not multi-line and so on, right? It doesn't make sense to have a multi-line email address, and that is already encompassed in this email regular expression. So we do not need to create additional validation for emptiness and multi-line, right? But with something like a to-do name or note body, we do need to account for all of these things separately. So let's get right to it, right? We already have the failures which we have created in the previous part, that is exceeding length, empty, multi-line, and list too long. And these are all for the notes feature of our app for the domain layer. And now we are going to create the validators which are possibly going to output these failures. So just like with the auth feature validators, we are going to create these validators for the notes feature directly in the core folder. That's because they are kind of non-feature specific really. We should be able to validate maximum string length or that a string is not empty regardless of the feature which we are currently inside of. So that's why these validators go into the core folder. However, if you have really a feature specific validation, they should go into their respective feature folder and not into core. So the first validation function we are going to create is going to be validate max string length. It's going to have again an output of either value failure, which will hold a string failure, and if everything goes right, we are going to validate string length. So the return type when everything goes right is again just a string. It's gonna be called validate max string length. And it's going to accept a string input and also integer max length. And of course, the implementation of this function will be extremely simple. That's because really we are just going to check if input string dot length is less than or less or equal, of course, less or equal than max length. And in such a case, we are just going to return right string. So actually input, which is of type string. So we basically don't change anything. We just let the input string pass through. and everything is nice and dandy. However, if this condition is not true, that means we have gone over the maximum allowed length limit. What we are going to output is, of course, the left side of either, and it will hold a value failure dot exceeding length. And we are going to pass over there the failed value is input, and to let the user know in the UI what the maximum allowed length is, we are also going to include the max length in the failure. And just like that, we have implemented our first validator function. So let's go ahead and implement other ones as well. Actually, I'm going to completely copy the validate email address definition and use that as a template. So paste it over here. And by the way, you can always get the code which I write here from the link in the video description. So if you want to follow along at your own pace, be sure to check it out. So we are going to rename this function to validate string not empty. And again, this is absolutely simple. So if input is empty, we return left. Okay, actually, this is kind of a bad thing to do because we don't follow our own rules, sort of our own conventions, we could say, that we always return right and else statement returns left, right? Right is always returned from the actual if. So that's why I'm actually going to reverse this. So is not empty. If it's not empty, we're gonna return right, input. All right, now conventions are being followed and I am glad for that. And otherwise, if it is actually empty, we're gonna return left. And the failure here, of course, is going to be nothing else than the one we have created in the previous part, and that is value failure dot empty. And let's pass in the failed value, which is the input. Okay, so far so good, right? Now we are going to create another validation thingy, which is again going to be for a string, because let's face it, the user input mostly consists of strings, but the next validator is actually going to operate on a list. So that's also nice. But this one is again for a string, and this is going to validate that we have only a single line of text. This is going to be used for the to-do item names. So validate single line, and we're going to again check if input. And how can we check if something is a multi-line string? Well, what is the new line character? The new line character is, of course, the \n. So in such a case, we're gonna return left value failure dot multi-line, and the failed value will be input. And again, I have noticed that this does not follow our convention of returning right from the if statement, but I think we're going to have to live with this over here. So anyway, if the input does not contain the new line character, that means that it's just composed of a single line. So we're going to return right, which will contain the unchanged input. Okay, so this is it for the string validators, but then we have a special one right over here, which is used whenever we add a third to do. We're gonna be notified that we cannot have more than 3 to-dos, and this button will be disabled. And to guard our value objects, the list value object, which we are going to create in just a bit, so that it cannot have more than 3 items, we need to create a validate max list length validation function. So let's again paste the thing which I have copied, but we're going to change much more than just the name of the function. Of course, let's change the name first. Validate MaxListLength. But in addition to changing the name, we are also going to change the types on which we operate. So value failure will hold the failed value, which is going to be a KT list, holding T. So it's basically just generic. And also the correct value, which is going to be returned when everything is fine. We have validated that the list contains like 3 or less than 3 items. Then we want to return again right KT list holding T. The input will again be KT list T. And oh, of course, you may be wondering, like, what are we doing with these KT lists? Can we just use regular lists? And the answer is that, yeah, we sort of could use just regular lists, but they are not immutable. So you can modify regular lists in place, and you are just going to not get a copy of that list. You're just going to basically modify the memory of the old list, the places in memory which the old list occupies. And this can create a bunch of problems. We want to keep this whole app very functional. So that means we do not want any mutability, or at least we want to keep mutability to the minimum. So that's why we're going to use KT list from the KT-Dart package, which we are going to import in just a bit. And of course, we are using the generic type T in this function definition. And this means that we also need to make this whole function generic. So the T will be the generic type of this function. And in addition to just holding the input being the KT list, this function will also accept an integer max length. So this is again going to be just like with the validate max string length, where we need to know of the max length. In order to use this KT list though, we first need to add the KT-Dart library. And if you are wondering what this KT means, yes, it means Kotlin. And this library is made by an awesome person with the name of Pascal Welsh. And it's really cool because it brings some of the Kotlin functionality over to Dart, for example, immutable collections. And if you are thinking that, hey, but the darts library, which we are using, for example, for the either or option types, this one also comes with something called iList, right? We could technically use that. It's also immutable, but I just don't necessarily like its interface. So that's why I will rather bring in another library with the name of KT list, because it's just easier to use in my opinion. So let's go ahead and inside PubSpec YAML, we're going to use our trusty add dependency thingy from the PubSpec assist extension, and we're going to add KT-Dart. With this done, we are currently at the version 0.7.0 plus 1. We're going to save our pubspec.yaml. And now we should be able to import the KT list over here, right? So let's import kt.dart. And just like that, we have access to KT list, and we can use it inside our validation function. So if input, and we are not going to say a length, but size, because it copies the Kotlin way of doing things. And in Kotlin, collections do not have a length, but they have a size instead, but it's basically the same thing. And if its size is less or equal than max length, we're going to output right and unchanged input. Otherwise, Just like in the case of validating a string length, we're gonna return left, value failure, and it's going to be list too long, failed value is input, and max is nothing else than max length. And with this done, we are basically done with our validators. So we have just created 4 of them for the string length, string not empty, single line, and max list length. And the max list length operates on an immutable KT list. Again, you can get all of this code from the link in the video description. But let's continue. Let's go ahead and create the value objects which are going to be needed in the notes feature. So again, what do we want to have here? We want to have note body. We want to have a to-do name and also note color. And I hope I didn't forget about anything else. So we are going to go ahead and create a new folder under domain. It's gonna be called notes. And over there, under this folder, we are going to create a new file, valueObjects.dart. And let's go ahead and create our value objects over here. Actually, I have just remembered that the value objects which I have forgotten to mention is of course the list itself, because the list needs to be able to validate that it has only 3 items at maximum. So this is a value object in itself. So we're gonna have 4 value objects actually. The first one is going to be the note body. And again, we're going to use our trusty code snippet, which you may already have in your VS Code from the previous parts. If not, go check it out. Or you can always copy the code which is already finished over from the link in the video description. So we are going to use VOBJ snippet. We're going to call this one note body. It's gonna be a value object operating on a string. And yeah, so now we can insert validation. But before we do that, I should actually fix my code snippet, but hey, whatever. The value failure also needs to be provided a type, and it is going to be a string. Just like this. And now we need to import our value object base class, also either from the darts package, also value failure. And now we should be good to go. So what do we want to do here? Well, we want to validate the max length of the string. And we also want to validate that the string is not empty. So we are gonna need to combine multiple validators together, while in the auth feature, we have only one validator like this. So we're again going to be fancy and assert in this factory that input doesn't equal null. If it doesn't, we can continue. So the first thing we want to validate here is validate max length, string length, of course. We're going to validate the input and max length. We could just hard code it over here to, for example, 1000 characters. But what we should do instead is create a static constant max length and make it equal to 1000. This way we can know what the actual max length is of the node body by just accessing the class's static member. And we do not need to check out its code manually and hard code values all over the place. So whenever you can create a constant, just do it. You are going to save yourself some headaches in the future. So we're going to use the max length over here and pass it over to the validation function. And this way we have just successfully implemented the first validator. So if something is passed in and that string is over 1000 characters long, we are going to get a failure instead of the actual value inside the value object. The problem is that we also want to validate with another validator, and that is the string not empty. So how can we do that? Well, we are going to use some functional programming skills, and we're going to use a Flatmap. Flatmap is something you may have already heard of in the realm of streams or lists. And what it basically does is that it takes in the value from over here on which we are actually binding this Flatmap. So it's going to receive a string. You see, this A is of type string. For explanation purposes, although you're probably never gonna see this in real life, we can rename this A to value from previous function, from previous f. Okay. And now we can take this value from previous function and run it through another validator of ours, which is going to be validate string not empty, and pass in not the input, but instead the value from previous function, like this. And the beautiful property of the Flatmap function, which is also in some circles called bind, they are just synonyms, Flatmap and bind, is that if the first function on which we are chaining the Flatmap returns left value failure, this means that the input is over 1000 characters long. In this case, this Flatmap and whatever it calls is going to be skipped, okay? This is very much like in an if statement where it short circuits. For example, if you have something like, let's just hard code some nonsense here, false and true, right? Well, you should not have true and false hard-coded inside an if statement, but also that true is therefore dead code. Why is true dead code? Why is it sort of like less colorful here? This is because AND statements short circuit. If something is false, you surely know that just a single value which is false inside an AND expression makes that expression false. So there is no point in evaluating this true expression, sort of, when we already know that the whole AND expression is going to not pass, right? The same thing happens here with either. If we know that either is already left value failure, we know that it doesn't make sense to perform any further validation. By the way, if you are interested in details, this is called the right bias of either, and also option is right biased. Again, if option is some, it's gonna continue in flat mapping. If option is none, it's not gonna continue. The same goes for either. If either is right, it's going to continue with flat mapping or mapping or whatever. If it's left, it's not gonna continue with flat mapping or mapping. This is called the right bias of either. All right, with this kind of an extensive explanation, what we are now going to do is simplify this horrible mess which we have created here. So we are not even going to need to have an anonymous function here. We can actually delete the parentheses and the arrow and not even pass anything into the validate string not empty, and just provide the function definition itself, and also remove the semicolon which was over there for some reason. Actually, what's going on? Maybe I have forgotten about one parenthesis. All right, now we're cool. So what we are doing over here is that we are flat mapping and passing in the function definition which works because it itself takes in only a single string. And the definition of Flatmap's function is such that it needs to take in a single string. So this contract is fulfilled. That's why we can just pass our function instance over there. Let's put a comma over here to make it format nicely. Once we know how to chain multiple validations together, implementing the other validated value object, it's gonna be very simple. Let me just copy the node body and let's paste it below. We're going to use Control or Command D while highlighting node body. That's because we wanna rename this class to toDoName. And as such, toDoName has max length of, let's say, only 30 characters. Let's save that. And it's also going to validate MaxStringLength. It's also going to not be empty. But in addition to this, we also want to Flatmap that it's going to be only single line. So validate single line like this. And as such, we have just implemented toDoName successfully, which is also, in addition to being limited in length and not empty, single line. The next value object we are going to implement will be a little bit special. That's because it's not even going to be validated. And I am talking about the node color. As you can see, we can choose from a list of colors. This list of predefined colors will be available in the node color. And over here, we basically can just pick from these predefined colors, but possibly you could allow the user to select some kind of a custom color. And it may happen that the color which the user selects is going to be transparent. Again, this is a very, very secure app we are building, definitely not some kind of a notes app. We are building something which needs to have data integrity from the client code in Flutter all the way to the server. We need to completely secure it. We cannot allow any possible mistakes to be made because, for example, we are building some, I don't know, some medical appliance or whatever. We do not want to have any errors here. We need to make sure that everything is always in valid state, all right? But we are going to make this example when it comes to node colors. So in this case, node colors, we tell ourselves that they cannot have any sort of a transparency. So we always need to transform the color which the user inputs as a custom color and strip away its transparency. So that's what we are gonna do over here in just a bit. Let's create a value object, VOBJ, node color. Value object will operate on color. And let's import color from Dart UI to make it independent on Flutter. And the value failure will hold color. Again, add the assert to the factory that the input is not null. And now let's just provide the list of predefined colors. So it's gonna be static const list color. Here we are making this list inside the node color class itself. I think that's cool, but you could possibly also take these predefined colors from some like shared preferences or some other kind of a database. For simplicity though, we are hard coding constants in this tutorial app. So let's call it predefined colors. And it's gonna be equal to a list of colors. And in order to not bore you with writing out these colors, I'm just going to copy them from the already finished code, and I encourage you to do the same from the link in the video description. So we have actual names of the colors. The first one represents the material canvas color, and then we have salmon, mustard, tea, flamingo, tortilla, and cream. All right, so now that we have these predefined colors, and we know that the user is never going to input his own color by himself or by herself, we could possibly just have something like write input. And this would make any input which is being passed in here to be correct. But we want to make sure that if the user inputs a custom color and that color contains transparency, something like not FF, which means full transparency, but something like, I don't know, 7/8 could be, this makes this color transparent. And we want to take this transparency, this 7/8, and turn it into FF always to make it fully opaque. So we are going to create not a value validator, but instead a value transformer for this kind of a functionality. So just like we have value validators .dart inside the core folder, we are also going to now create a new file, value transformers .dart, and inside of here it's gonna be not even similar to validators, it's going to be much simpler. This function will just return not either failure or string or whatever, it's just going to return a simple color, again from Dart UI, and we are going to call it make color opaque. It's gonna accept a color, which we of course want to make opaque. And as I said, let's import stuff from Dart UI. And what do we want to do here? Well, return color dot with opacity 1. Easy as that. And now that we have this value transformer, we're gonna go ahead over to value objects.dart. And what we are gonna do is simply wrap the input inside the right of either with make color opaque, passing the input, and we are done with the node color. Now, no matter what is passed over here, we can rest assured that the color will not have its alpha channel messed with. Now for the last and possibly most interesting value object of the nodes feature. This one is going to be a list which can hold only 3 items and never more. So this one is going to be called list3, and just to make our lives a bit simpler, let's copy the to-do name class definition and paste it below. So let's again highlight to-do name and hit Control D or Command D. I hope on Mac the keyboard shortcut is such. If not, let's just, you can always modify it manually. So let's rename it to list3. We are going to make it a generic class holding type T, because as all lists, this list can also hold whatever it chooses to hold, not just a single type. And the value object will hold KT list, so the immutable variant of a list of T. So far so good. Let's import kt.dart, and let's also change all occurrences of string to kt list. So the value will be either value failure kt list. Also the input will be a kt list holding the T generic type. The max length will be only 3, not 30. And it will have only one validation, and that is validate max list length. Input and max length are cool here. And as such, we have just created a list which can hold only 3 items. But I would not stop here, because this is a list. And for lists, it's pretty common to try to get the length. And in case of this list, we also want to be able to check if the list is already full. That means if it contains 3 items already. And just like your regular old list provides you with handy getters to obtain this kind of information of its size or length, we are also going to create custom getters for our list 3. So the first one is going to simply obtain the length of the list, length, and it's going to need to be a bit more elaborate than just calling size or length of the KT list. That's because we need to first make sure that the value is actually on the right side of either, because if either holds value failure, then of course the length is just 0. If something is invalid, its length is going to be 0 in our case. So that's why we're going to return value dot get or else. This get or else will return this function return value whenever the value failure is present inside either. So in the case of failure, we want to have an empty list. This is just a simple function from the KT Dart library. It simply returns an empty KT list with the length of 0. And we want to get its size. So this way, whenever there is a failure of our list, that means that it somehow holds more than 3 items, the length getter will return 0. And by the way, we are creating these custom getters in our list3 class precisely for the reason that we don't want to litter our code base with these kinds of calls to get or else, value and all that. No, we want our code base to be as clean as possible. From other places in our code, we are just going to call the length getter, and the details how we operate inside this length getter are going to be hidden. And the next getter we want to have here is just a simple boolean get is full. This is a very domain specific term for this list, because mostly lists just cannot be full. They have technically infinite length until you run out of memory, of course, but this list is actually going to be able to be full. So we just want to return, and a little bit of an inception is going to be going on here, because we are going to use our length getter, which we have created in just a while ago, and we are going to return length is equal to max length, which is our constant. So this way we return a boolean, which is true if the list is full already. And that's it for this part of this DDD tutorial series in Flutter, where we have created value validators, value transformer, and also all of these beautiful validated value objects. If you want to go over this code at your own pace, check out the link from the video description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education. And by the way, link is also in the video description to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this, for example, the next part where we are actually going to take all of these value objects and put them into nice entities for note and to-dos, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, give it a like and also share it with other people who are surely gonna find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.